Hi, today I want to talk about how to calculate arc length using integral. So basically arc length is that given the function we want to calculate the length of this line here. And then with the methodology or the idea of integral, we can basically on both x and y we can cut this line into a very small interval on both of both x and y, so that the arc length is just a summation of all these small interval, and this interval basically is just the square root of dx squared plus dy squared, basically just to calculate the third length of a triangle. And and if we so like if we can divide it dx on both so first of all we have a dx squared plus dy squared, but now let's divide it dx squared for in both two terms, so that we'll get 1 plus dy over dx and then square, and then take the square root is the uh, arc length for each small interval, and then we take the integral over the interval. That will give us the arc length. So for example, let's say we have a function that is equal to x to the power of 3, and then take the square root, and then we need to calculate the arc length over from 0 to 28. So applying this formula, so this is something you need to memorize it. So applying this formula here, so and then we need to take the derivative of this function in terms of x. So basically that's just 3 over 2, and then x to the power of 1 squared. So that is just a square root of x, and then substitute dy dx into the formula here, and then we can calculate the arc length. And here we use substitution to set u equal to 1 plus whatever it is in the square root, and then du is just like 9 over 4 dx, and then substitute both u and u and du into the original function. We have a square root of u equal to 4 over 9 du, since du is equal to 9 over 4 dx, so dx itself is equal to 4 over 9 du. And here we just after the integral, and then we need to substitute back from the u into our original function, so that we can express our solution in terms of x rather than u. And then we also need to substitute both 28 and 0 into the formula, and then this is the final solution of the arc length. So the idea is to use this formula here. So and then to calculate the length of uh, um, of the original arc length by cutting into smaller pieces, and then sum each length by over the interval, and then we will get the total arc length. So that is the idea, and then this is the formula. So thank you very much, and let me know if you have any question.